Guys, welcome to another part of the Ventilators series video. In this video, we will cover turbine-based ventilator, blower-based ventilator, servo-controlled ventilator, and modes in ventilators. Let's begin with turbine-based ventilators. The independence turbine-based ventilation technology provides makes it an interesting alternative for hospitals. But that doesn't mean that patients won't benefit as well. In many ways, turbine technology actually offers superior performance. One example, non-invasive ventilation using masks, NIV. With NIV, leaks are a common issue. Modern NIV-capable ventilators use sophisticated leak detection algorithms to compensate for leaks, maintaining volume delivery in spite of even large leaks. Without a steady supply of compressed air, a gas-driven ventilator will not be able to generate sufficient flow in order to meet the demand. Turbine-based ventilators can provide enough flow to effectively compensate for even the largest leaks. Next is blower-based ventilators. Mechanical ventilator systems driven by blowers are in rapid development. Market demand is strongly growing, mainly due to large benefits of these small-size ventilators. As a pressurized gas source is omitted, blower-driven ventilators can be easily transported within hospitals for emergency use. This leads to easy logistics as well as avoidance of multiple patients, dis, and reconnections, which is the case when using conventional ventilators. Ventilators equipped with well-designed blowers provide high performance, low noise, low energy consumption, and a high reliability. Such high-performing blower can even facilitate operation without internal flow valves, allowing manufacturers to develop ventilators with less complexity and costs. Reliability and long lifetime are a vital essence for mechanical ventilators. Let's know about servo-controlled ventilators. Intensive care environments around the world revolutionized in 1971 by the introduction of the first Servo 900 ventilator, Elmer Schkonada. Constructed by Bjorn Johnson, it was a small, silent, and effective electronic ventilator, with a famous servo feedback system controlling what had been set and regulating delivery. For the first time, the machine could deliver the set volume in volume control ventilation. It uses the hospital medical air and oxygen for the electronically controlled ventilation for the patient. Let's know about different ventilation methods. Let's begin with volume-controlled ventilation. During volume-controlled ventilation, the set tidal volume is supplied by the ventilator at a constant flow. The inspiratory pressure is the resulting variable and changes dependent on the changing lung mechanics. Volume-controlled ventilation has different modes. They are as follows: volume control, continuous mandatory ventilation; volume control, assist control; volume control, synchronized intermittent mandatory ventilation; volume control, mandatory minute volume. The next ventilation method is pressure-controlled ventilation. During pressure-controlled ventilation, two pressure levels are kept constant: the lower pressure level, PEEP, and the upper pressure level, inspiratory pressure. The volume and the decelerating flow are the resulting variables and can vary dependent on changes in the lung mechanics. Pressure-controlled ventilation has different modes. They are as follows: continuous mandatory ventilation, assist control, synchronized intermittent mandatory ventilation, biphasic positive airway pressure, airway pressure release ventilation, pressure support ventilation. All modes are controlled with pressure-related settings. The next ventilation method is spontaneous ventilation modes. During the spontaneous ventilation modes, the patient carries out the majority of the breathing effort. The pressure level, PEEP, CPAP, at which spontaneous breathing takes place, can be adjusted. In all spontaneous ventilation modes, the spontaneous breaths can be supported mechanically. Spontaneous ventilation modes has different modes. They are as follows: spontaneous, continuous positive airway pressure, pressure support; variable pressure support; spontaneous, continuous positive airway pressure, volume support; spontaneous, proportional pressure support. There are some special ventilation technique, which is also known as dual ventilation mode, which consists of PRVC, AV, APS, and so on, but they work as same as all. At last, let's wrap up with neonatal ventilation modes. Since the ventilation treatment for neonatals differs in parts from that for adults, specific modes are available for neonatal patients. The following modes can be used in particular for neonatal patients: spontaneous, continuous positive airway pressure, pressure control, high frequency oscillation, pressure control, mandatory minute volume. These modes are commonly used in all the conventional ventilators in hospital, but every manufacturer has given different terminology according to their standards. Understanding the flow, volume, pressure is important in ventilators. In the next video, we will learn the definitions of all the modes we mentioned in this video.